Everyone, my name is Luqman Theory. I'll be going over the portion of my project and the problems that I solved in this project, going over the library management system using a binary search tree, a hash table for student records, and the red-black tree. So I'll be going over the structures I use to organize and manage records and data in an efficient manner, and the operations I use, such as insertion, deletion, retrieval, and traversal. And I'll break down the logic for each question while going over the parts that I implemented. Starting off, I will be going over the hash table implementation. Starting with the hash table implementation right here, we can see in this portion the problem involves managing student records using the hash table. Each record has a unique student ID, a name, and a GPA. The hash table is implemented using Python dictionaries, making insertion, retrieval, and deletion efficient. The following functions that I added were insert function, the retrieval function, and the delete function. The insert function, it works by adding a new student record to the hash table and make sure that no duplicate record is already in the hash table, and it checks the student ID. If it is, then it gives you an appropriate response. If it isn't, it adds it with the response as well. The retrieval function, this function retrieves the student record using the student ID as a key. If the record is not found, it adds a print statement that lets you know that it's not there, and if it isn't, it gives you the information appropriate. The delete function, this function removes a student record by searching with the student ID. If the ID does not exist, it tells us, and if it does, it deletes it. The functions used here allow for dynamic and efficient management of student records, and as demonstrated with the examples where we added, retrieved, and deleted records. Moving on. Here in this problem, we used binary search trees to manage books, each node in the tree representing a book and containing its title, an author, and the year of publication. The tree is organized by the title of the book, allowing for efficient operations. The additions I made to the code are the insert function, the search function, and the traversal options. Starting with the insert functions, this function inserts each book into the correct position in the tree based on its title. It avoids duplicate entries by comparing the title with existing nodes. The search function, this function searches for a book by its title. It traverses the tree to find the node and returns the details. And the traversal options, these three traversal options, in order, pre-order, and post-order. In order, it lists the books alphabetically. Pre-order displays the structure of the tree, and it is useful for the arrangement. And post-order, this processes nodes from bottom up, which is helpful for the deletion if needed. These additions were demonstrated in the example with several book titles, showing how the tree organizes and retrieves them as such. And lastly, the third implementation uses red-black tree, a self-balancing binary search tree. This structure ensures that the tree remains balanced after every insertion, maintaining fast operations. Each book node includes its ISBN its title, author,